So let's look at this other question, trigonometric question. It is harder again. It is a quadratic within the trigonometric equation. You can use quadratic formula or you can use factoring, whichever you like. It doesn't matter. Remember that the coefficients of a, b, c for the quadratic will be 6 and b is -1 and c is -1. You can plug it in there and you can do the math on that one, or you can factor. It doesn't matter. So let's do the factoring. I'm going to go ahead with the factoring piece. So 3 sine, all right, so you get 3 sine x plus 1 times 2 sine x minus 1, set that equal to 0. And in case you've forgotten how to do that again, right, you can expand that and figure out that, oh, that's -1. We get the negative sine x left when you expand that. So that sounds very good. And then zero product rule. So 3 sine x plus 1, set that equal to 0. Or 2 sine x minus 1, set that equal to 0. And then solve each equation. And what you will get is you get sine x equal to -1, 1/3, or sine x equal to 1/2. Now we're going to go ahead and solve for the angle x. So x is basically sine inverse of -1/3. Okay, and then in this case, just before we continue, let's do the cast quickly. Sine is negative in what quadrant? Okay, so we're looking at this equation first. Sine is negative in quadrant 3 and quadrant 4. All right, so you take out your calculator and punch that in, -1/3, sine inverse of that. Let's see what. Okay, I got the first angle equal to -0.3398, and let's locate that. Well, that angle is in here is negative, so -0.3398. okay, but what we want is the standard position angle, which is that one. So that would be 2 pi minus 0.3398, whatever that is, and that will give you 5.94. Remember, 2 pi minus that will give you the standard position angle, 5.94. So that's the in quadrant 4. Remember, we need to find another one in quadrant 3, but it will have the same reference angle of 0.3398. Remember, the reference angle to -0.3398 is the positive of itself, 0.3398. So how would you get the second angle, x2? And the x2 will end up being pi plus 0.3398. And that is 3.48. Excellent. So we got the two angles in quadrant 4, one angle in quadrant 4, the angle in quadrant 3. These two are solutions to the first equation. Okay, and while we're at it, perhaps we can put it into general form. So let's do that. So x1 for the general term will be 5.94 plus 2n pi, and 2 pi is the period of this function and belongs to the integer number set, and x2 is 3.48 plus 2n pi. So these two are the general solutions for this equation. Great. The next equation we have to deal with is the second equation right here. So, and that's what we have to do now. Let's go ahead and solve that. So we have sine of x equals to half. Remember the cast again. And sine is positive in quadrant 1 and quadrant 2. All right, and in this one is actually quite straightforward. So we know that the sine inverse of a half, special angle, that's pi/6. So very simply, you can quickly sketch that right here. So that's pi/6, a standard position angle. It's its own reference angle. That's your θ1 or x1. And then we need to find the second angle, which is this one right here, quadrant 2, but it has the same reference angle of pi over 6. Excellent. So what we're going to do, so x2 must be pi minus pi over 6, which will end up being 5 pi over 6. Okay, and then if we change both of them into general form, the first one will be pi over 6 plus 2n pi, and x2 will be 5 pi over 6 plus 2n pi. Don't forget to include what n is. N belongs to the integer number set. Okay, I. All right, those are the two. So all together, how many solutions? We have 4 solutions again, because we have had quadratic trigonometric equation. This was the original equation that we got. So we got 4 possible answers that we came up with. Remember, I used factoring to do this, but you could use quadratic formula and you will get the exact same answers. All right, you just have to go through the cast and get those values. All right, so we just covered 2 of the most difficult equations, trigonometric equations. The type of equations are more complicated, so make sure you do a lot of these so that you understand the process, so that you're comfortable with that. Okay.